Hello friends, welcome back in this video session of refrigeration and air conditioning subject. Today we are going to learn different materials used for duct. My name is Mr. S.V. Kumbhar, Assistant Professor, Sharad Institute of Technology, College of Engineering, Yadra, Ichalkaranji. So before going to start different duct materials, let us quickly review some part that we had already studied. Duct work consideration. So while designing a duct, we have to first of all select shape of duct, whether we require circular shape or rectangular shape or flexible shape. Depending upon that, we have to choose duct material. Second, size. The size of duct is different for different applications. For example, in case of hospital, auditorium, theater, hospitals, hotels, etc., different size of duct is required. So size also matter. Aspect ratio, as we had already learned so many times, aspect ratio is the ratio of length of longest length upon smaller length. Velocity of air flowing through duct, that is the next parameter. Pressure of a system, static pressure of a system, which is the pressure difference between inlet and exit. Space conflicts, space requirements, that is one more consideration while designing a duct. So these are the different terms used in air conditioning system: aspect ratio, flexible ductwork, overhead system, underflow air distribution system UFAD, displacement system, dumping, diffuser, grill, register, slot, diffuser, shift zone and plenum. So this is today's important part, materials used for duct. Now there are many materials used for duct system, that is sheet metal, flexible and other types of material, out of which sheet metal is widely used. Generally sheet thickness is measured in gauges, right? So this sheet may be made up of galvanized iron, aluminum and stainless steel. But again, most commonly material used is galvanized iron as well as aluminum, as aluminum is costlier than other, but still its weight is low, that's why it is widely used. Another different materials used for duct is flexible. Flexible material include insulated part. In some cases we need to insulate duct material. Another material is tube or socks. Tubes are used to carry conditioned air to a space to be conditioned. In other, PVC pipes, fiberglass, this can be also used as duct material. This is some congested corridors. Different ducts materials are shown which are insulated. This white colored part, it is clearly visible for congested corridors. This is the shape and size of duct material: rectangular, round and oval. So if we compare these three shapes, rectangular duct is preferred because of its simple in construction and of low cost. This is the rectangular duct material where aspect ratio plays very important role. Aspect ratio is the ratio of highest length to lowest length. W is its width, that is highest length, and D, that is depth, is its lowest length. So W by D is its aspect ratio, and aspect ratio 1 to 1 is nothing but square. So velocity and area have an inverse relationship with CFM. CFM is equal to velocity into area. Velocity and pressure drop have a direct relationship. Air distribution system. There are three types of air distribution system: above ceiling, displacement, and underfloor ventilation air. So here you will see one by one. This is above ceiling distribution system, in which this is the supply air duct, which will supply air to each and every room, and after that air will be returned through this duct. Dilute the air. Sometimes after continuous supply of conditioned air, we have to dilute some amount of air. For that purpose, this dilute air is diluted, and that conditioned air is sent to final application. Outside air versus fresh air. Now, if outside air continuously mixes with conditioned air, what will happen? The load on air conditioner will go on increasing. So some sources of outside air must be carefully considered. For example, a space between window, air may enter to inside room through that gap which is present there, as well as the space between two parts of door, and many more. So we have to pre-filter or condition that air, and that air has to be distributed. Other design consideration: thermal mass, mixed air, energy in the air prevailing, the amount of water in the air, that is we call it as moisture. These parameters has to be considered. So these are the different diffuser, grill or resistors. These are some photographs of different diffusers, grills or resistors. This is short circuiting. Displacement principles. So one photograph is shown where displacement diffuser is recessed in wall. So generally conditioned air moves upward past the person breathing zone, that we call it as breathing zone. This invisible film continues an upward movement towards the ceiling. But a person will breathe lower contaminant level with respect to a mixing design. Okay, this picture shows the occupied zone which has to be conditioned properly. So the line below a red color is the occupied zone. It will be occupied after some time. As it is a hotel, it will be occupied after some time. So in this zone, conditioned air should be properly circulated. But the zone which is above the red line, it is unoccupied zone. So the temperature gradient is shown here. Blue color line, it indicates temperature gradient, right? So temperature gradient suddenly decreases below the red zone. By only cooling the occupied zone, tonnage of requirements may be reduced. Means only that part up to the red mark, that zone should be conditioned, and above part it is not necessary to condition. That is nothing but thermal displacement ventilation. This displacement delivers fresh air where it is needed. So lower particulate concentration than any mixing system. Displacement increases use of outdoor air without energy penalty, because tremendous amount of energy can be saved if we do such things. Quiet diffuser, draftless condition for the occupants. Advantages. Here first advantage, it is very quiet. Second, moderate supply of air. Third, low velocity of air which is to be conditioned. Air delivered to the comfort zone with without mixing aesthetics. It can accommodate more outside air for same energy cost, but its cost is high at initial level. You might have seen such system in supermarkets. In supermarkets, generally some part is only air conditioned and remaining part is not conditioned. So first disadvantage, high cost, less well when it is above 100 feet, etc. Underfloor system. So the figure shows underfloor system which reduces floor to floor height. So this is the underfloor system. Air delivery HVAC diffusers. These are the diffuser which are considered as passive self diffuser or pressurized plenum where displacement theory can be easily used. So these fans are situated inside floor so that occupant may control airflow volume around that diffuser. So this is the rooftop chiller heating, ventilation and air conditioning solution. So supply duct is also shown there. This is the supply duct. Supply air, stub duct, chilled water supply and return, indoor air handling system, and cooling tower which is placed at topmost condition. So take away, it eliminates the contaminant is always the first step. We have to capture. If we can't eliminate it, healthy buildings are well ventilated with the help of this. Operating cost and usually first cost go up as our ventilation goes up. This is access floor which is shown in this picture. So these are the computer rooms. These are computer controlled right now. Thank you. Thank you very much.